All right, so we're going to look at latitude and longitudes of the world. So all this is we are going to do practical questions using those circle formulas we just did pretty much, but in a practical aspect. So obviously you've got the world, and we're going to say for this, all of our questions, that the world is a perfect sphere, so a perfect circle. And we're going to, when they're going to talk about circles, they're going to talk about latitude and longitude. So if you look, the longitude ones, circles, are the ones that go from, like, say, the North Pole down to the South Pole. So could you see, say the one I just highlighted, if I, like, just brought that circle out, I'd have, like, a circle like that, wouldn't I? So say there's North Pole, there's South Pole. Can you see that? Yeah. And it would go around the whole world, wouldn't it? So when they go around the whole world, so that, like, from the north to the south, that's a longitude. And we call the longitudes, they're generally called, and it'll come up in the next notes, but they're called a great circle. Why is it a great circle? Because it's the fullest size of the world, isn't it? It's not a mini, it's the biggest one we can get, going right around. Now they keep going all around, so there's all these other ones that could go around like that. So there. When you have latitude, that's going around like you can sort of think of it as a ladder. It's like these ones there, yeah, going up like that. So say I drag this one out, it would be like a circle like that. But it's not, when you're down the bottom of the circle, it's not the biggest size it could be, could it? There's only one latitude, that's the big one, and that is the one in the middle, because you can see when you're in the middle, I'll just draw it in another colour. When you're in the middle, you end up getting the biggest circle you can get, can't you? And what do you reckon what's the middle circle thing in the world? What do we call... No, what's the equator? Good, it's the equator. So the equator is a measure of latitude, yeah? So the equator is the middle latitude. So we climb up. So what we often say is that's the 0 latitude. So we mark that from the middle. If you go down that way and you go down to this one down here, they'll tell you you're south, so it'll have a south name, and it'll tell you how many degrees you've dropped down by. So we'll see that in a minute. So let's go along. All right, so here you go. There you go. I just talked about it. So we're going to make sure this is a latitude, yeah, but that's only that one's a great circle. And what did you just tell me it was? It's called the equator. Good. So, and the equator, we often say, is 0 latitude. You haven't moved from the middle up or down, okay? And it's a great circle. These other ones are small circles because they're not a full width. So this one up here, this is still a latitude, and it will be so many, they'll tell you it's north, and it'll tell you so many degrees from the equator, yeah? So because what we're going to say is you draw like a line and you say you've gone up that much degrees, all right? So let's have a look. So we've talked about that. So don't worry, sometimes they call, and I think they're only using them in your textbook, they say meridians of longitude. Whatever, it's just longitude. It's a long-worded way of saying longitude. They've called them. But I think they're always going to say, don't worry about the word in front, they're going to say longitude, okay? So longitude, remember, they're the ones going down like that, okay? And latitudes are the ones coming up. So if you have a look here, I'm just going to zoom in a little bit. So can you see here? Here's our equator. This is what I said was the equator. Now, can you see when we go up onto this one up here, see how it's called 0 degrees north? So I know that's a latitude. So remember, you might want to write here, latitudes are always north or south readings, unless you're on the equator. North or south. So if you go down here, see how you're 60 degrees south? That would be the latitude you're on. And if you have a look, it shows you in there how they're measuring it. So if I was like sitting up on that flat surface of the equator circle, and then I go up to here, that's what they're saying. That degree there is 60 to go from flat up, and that's how they're working it up. So you know this up here, this is a latitude, and you've gone up above the equator, and this is a small circle. It's not a big circle. Small circle. Oh, God. Yeah. It's a small circle, that one. And so it's like south. All right? So here they're just showing you how you work out angles of latitude. So it is just telling you where you go. If you're actually, so just take note of this. If you're at 90 degrees north, you're at the North Pole because you've gone exactly this whole angle. Can you see you've gone from the equator up to north is 90. So if you're at 90 degrees south, you're at South Pole or Antarctica, yeah? Okay. All right. Okay, so main thing you need to remember, latitudes are north and south. All right. Boys, now, longitudes, so they're the ones going, they're always a big circle. Oops, sorry, I'll do it back. I'll do it in red. So they're always big circles. So always that. Now what they do is, if I just going to do this, you've got, this is your longitude. You have 0 degrees that way as well. And that is called the prime meridian. So you know how we had the equator the other way? This one in longitude is our longitude one, and it's called prime meridian. Okay, now where you go from there, they will tell you which way you swing. So if you were over this one, like that, that will be you've gone east of the 0. So it'll say you're east, and it'll tell you so many degrees, so maybe 30 degrees or whatever. Okay? So, and then if you go this way, you're going west. So can you see longitudes are always an east or west measurement? Oops. Okay? Yeah, over here. They've got west here, see? And do you want me to draw one?
No, see, that one over there. But on that side is west.
No, this is east. This side's east, and this is west. Okay? Yeah, no, be careful. Alright, so, okay. Alright, so down here they've said that Melbourne has a latitude of 37 degrees south and a longitude of 144.9 degrees east. So say I drew the world, thinking this is the world, right? And we know the equator is 0. And we know that the prime meridian is also 0. What we're saying when we say that Melbourne is 37 degrees south, so we're down here, aren't we, on that line? So I'm going to say that's the south 37, roughly, degrees, yeah? And the longitude is gone to the east, so it's like on that longitude. So that's east 144 or whatever degrees. So see how that's where Melbourne would be. And that, if you think about the world, I know I'm a bit off, but Australia's down there, isn't it?
Is that what you did?
Yeah. So it's pinpointing where you are. So that's how your GPS or your phones, they're pinpointing that what latitude you're on and what longitude you're on. And that's what they're doing. Okay? So the other thing that's going to become a big factor, but they will generally state it in every question. They're going to say that the radius of the Earth is 6,400 kilometres. That's the generalised radius. It's probably a little bit different, but that. So that is, just be careful, you might want to write that is the radius of a big circle, of a great circle. Not a small one, a great circle. So it's the radius of a longitude and the radius of the equator circle only.
So is this the stuff, the only stuff we need to know?
Yeah, you're going to see the formulas to follow. Let's just keep going. All right. So let's have a look at some questions so you know what they're going to go with, all right? So don't stress. So it says Beijing, China and Perth, Australia have the coordinates of 40 degrees north and 116 degrees east. So they're saying this is Beijing, okay? And then they're saying this one is Perth, okay? All right. Calculate the shortest distance between them. So what you're going to see, can you see that they always are going to give you one that's the same? Can you see that this east is the same? See how they're on the same thing? So what they're saying, they're on the same longitude. I can't spell. Longitude. Is that right? Okay, so what has happened? Okay, we've got, if I drew out this longitude circle, I'll just draw the world. So we've got the world, and they're on the same longitude circle here, yeah? Whatever it is. Okay, and then they said, and remember you'd have your equator, which is 0. Here's the equator. Now, they're saying that Beijing is 40 degrees north, so it would be up here. So it's gone from the center of the earth up 40 degrees. And then it said Perth is 32 south. So from the equator, it went down 32 degrees. So can you see in there, and they've done it here, you can see how much degrees in the middle. So if I had this longitude circle, I drew that, I would have the center of the circle. I've got Beijing sitting out here. I've got Perth out here. I now know that there's 72 between them. Okay? So what I'm going to get, this arc length. So wouldn't the arc length formula, remember, it was pi times the radius times the angle over 180. Okay, what's the radius of a longitude circle? It's the Earth. Can you see there's the 72 degrees? Yeah? And there's the 180. So that's how they've worked that out. We have a formula. Once you know what you're on, if you know you've got the same longitude, you're going to see in the formula sheet, I've got it ready for you. So, if you look here, let's do this question. So the diagram below shows the positions of 3 cities A, B, C. According to the diagram, A is located on a longitude. So let's remember, longitudes are the ones going from the top pole to the bottom. So is longitude ever measured in north? No. So get rid of that one. Say, no, you're not right. B is located on a longitude of 20 degrees east. Is B on? No. No. Because would we have a longitude with... No, it's not. It's on the other side. It's not, okay? Yeah. So is C... Yeah, that's right. Is C located on a longitude of 40 degrees south? Do we have south for longitudes? No. We have east or west. A and B are located on the same longitude. They're not, are they? One's on this side, one's on the... No. So, and A and C are on the same longitude? Yeah, that's correct. Even if you're a bit unsure what's going on with B, you know for sure A and C are on the same one, aren't they? So we might not be 100% know what's going on. Is B over the other side? Who cares? I know A and B is definitely correct. So A and C are definitely, I can tell, on the same one. So there's your answer for that. So that was one questions. So here we've got to be careful when we're finding the distance between 2 points on the equator. Even though it's a latitude, the equator is a great circle, isn't it? Yeah? So it's a great circle. So its radius is still the radius equals the 6,400 kilometers. Okay? So if I had two countries on the same, so point A is 30 degrees west on the latitude 0. So can you see again, I told you, they're going to give you, something's going to be the same. So they're both on the same latitude, which is the equator. So if I had the equator here, they're both on that. All right. Now they said that, what was it? Point A is 30 degrees west. So if I had the whole world there, and that's the prime meridian here, 0. A is out west, so it's along there, and B is 90 degrees east, so it's out here. So if you think about it, it went out that way, what was it, 30 degrees? This guy went out that way, 90 degrees. So how much degrees in the middle? It's 120. So can you see there's where they found 120? So we're finding the arc length along the equator. Sorry, between there and there. All right. Here they're talking about some questions from the distance from the equator. So Melbourne has a latitude of 30 degrees south and a longitude of 145 degrees east. Find the distance of Melbourne to the equator. So can you see we're on, when they talk about, they say here's the equator, which is 0, and then Melbourne's down here on this latitude, which is 38 degrees. So you can see when we go to find the distance between them, we can just pretend we're on the same longitude and we're going around like that. So we can use the radius of a circle. So what we are here, when they say find the equator, we're on the same longitude. Okay? If we're down at the South Pole, what's the angle between those? If you're down at the South Pole? 90 degrees. Good. So, and, okay, so because we're saying South Pole's 90, but what we know, Melbourne's already gone 38, we've already gone 38 of the way. So can you see when you're trying to go from Melbourne to the South Pole, what you're saying is 90 minus the 38, which is 52. That's why they've done it. So when they say North Pole, we've got to go up this 38, and then we've got another 90 there. So what would that be? So plus 90. So the whole angle up there is 128. So there it goes. So you've got to remember how far you're moving around that big circle. All right. So to help you, we've put these formula sheets on your notes, and this is how I'm telling you it's going to get all easier now. So it says find the distance along the parallel of latitude. So if you have a look here, can you see we've got Western Australia on a latitude of 31, and we've got Tamworth on 31. Can you see that they're the same? Yeah? So what I want you to do, once you notice that, you say same latitude. If you look over here, you've got this formula sheet. Can you see it says, it says same latitude, okay? So when you've got the same latitude, you use that formula that they've got there. Now, the formula says you have to find the radius of the small circle first, because then when you're finding the distance, it has that radius in there. So first of all, we're going to look at this one. All right, we know it's the same latitude, and then they're saying find the distance between these two things. So I've gone to this formula over here. I've looked at my sheet. I know it's got the same latitude. So I've first got to find the radius. So the radius, the way you find that is 6,400 times cos and the angle of latitude. So what's the angle of latitude? 31. So you'll do that. And then, so when we go to find the distance between these two, we're going to go, the formula says here, pi times the radius of the small circle, which I just wrote there, 640 times cos 31. So that was the radius. That's that there. Then I go times the angle between the two longitudes. How much degrees is between these two? It is 29. So you go times 29 over 180. And then you do that and you'll get your answer to be roughly 2777. Okay? So now all you have to do is look at what one they're giving you the same and go find the formula. So I've blown it up here and we can see we've done it all down there as well. All right? The next question, and it says the city of Karachi in Pakistan has a latitude of 25 degrees north and a longitude of 67 degrees east. Assume the radius of the earth is 6,400. Find the shortest distance along the surface of the earth between Karachi and the North Pole. So if we're doing that, we are saying if you're going to find the shortest distance, you're going to be going on the same longitude, yeah? So we've got that we're on the same longitude here. Because you're on the surface of the earth and you're just going to go around. Now, they're saying between the North Pole and Karachi, which is 25 degrees north. So what we said is they moved up already 25 degrees. So how many degrees is in between them? How many does it take to go from 25 to 90? What is it? 65? Yeah? So you can see here, I've gone into my notes. I've found the one that says the same longitude, and off I go. Distance between 2 points on the same longitude is pi times 6,400 times the distance between the two latitudes. Well, Pakistan has 25 degrees north and the North Pole has 90 degrees north latitude. All right, so there's the difference. And how do we work it out? There's a formula. All right, so these formulas are in the back of your books to have quick access to them. Okay, so if you have to calculate the distance between the following A and B have the following longitudes. So if they have the following longitudes, it means they must be on the same latitudes because we only ever give one thing different. So off I've gone, I've found that thing and I've used that formula to find when you're on the same, see, distance on the same latitude, and off I go and do that. All right.